At this point in the course, you already learned a lot about some crucial core React concepts. And of course, you're going to learn even more throughout the rest of this course. But before you go there, before you dive deeper into React, I strongly recommend that you first practice what you learned, and that's exactly what this course section will be there for. In this course section, we're going to build two demo projects, two basic yet non-trivial demo projects, which allow you to apply your knowledge and to practice what you learned. Because in both projects, you'll need to work with components, state, some styling, and all these crucial core concepts we explored throughout the previous sections. Therefore, in this section here, you'll practice how to split an existing component and an existing application into multiple components, and you'll also practice how to build an application from scratch. You will practice how to work with state, how to manage and use state, and you'll practice outputting list and conditional content. Now, for both practice projects, which I prepared for you for this section here, I will give you an introduction to those projects. I'll provide you with some starting code, and I'll give you some tasks or show you how the finished project should look like. But I then absolutely would recommend that you first try solving these tasks and building those projects on your own before you then take a look at my example solution, which I, of course, will also provide as part of this section. Because by trying these things on your own first, you'll of course learn more about React, and you'll be able to confirm that you really understood all these core concepts up to this point. That being said, after every demo project introduction, I will provide you with detailed solution steps, allowing you to compare your solution to mine. And of course, whilst building that solution together with you, I'll also explain why I chose a certain approach and why I solved the tasks as I did solve them. So definitely take a look at my solution as well, but also definitely try those projects on your own first. Now, as mentioned, in this section here, we'll build two demo projects. And here's the first demo project which we'll build. An investment calculator where you can enter some data about your planned investment. For example, your current savings, the amount you're going to add every year, the expected return on investment, your time horizon, so the time frame of this investment. And then once you click calculate, you'll get a table with the results for this calculation, where you can see year by year how much interest you're going to gain and so on. This is the first example application we're going to build here, and for this application, I created a starting project, which you find attached. Of course, you also find a Code Sandbox link attached, in case you want to follow along there. And in this starting project, you'll find an image in the assets folder, and then some styles in the index CSS file, and then most importantly, you'll find an app.js file, which includes some JavaScript code, and also some JSX code, but which doesn't work yet. This doesn't do anything. Instead, in there, I added some to-dos and some hints or comments regarding your tasks and what you might want to do with that code. And I'll provide you with more detailed tasks in just a second. But you can and should use this code as a starting point because it also, for example, contains some code you could use for calculating these investment results, the interest gained per year, and so on. I already created this code for you so that you don't have to write it on your own and you don't have to come up with it on your own. And I also essentially created all or almost all the JSX code you're going to need, though of course the data is missing in that code. It's not dynamic code, instead it has some hard-coded placeholders, and it's of course not outputting any results. We're also not managing any state yet in this component, because that will all be things you should do. And therefore, here are your tasks for this first demo project. The first task is to take this one single app component that you find in the starting code and you split it up into multiple smaller components. It's up to you how granular you want to be, and it's up to you to identify suitable components, but you should at least be able to identify a few components you can split this one single component up into. So that will be the first task. Split the JSX code and the overall app component code into multiple components. As a next step thereafter, I want you to handle some events. To be precise, I want you to handle the submit event when this form here is being submitted, and I want you to handle the click event on that reset button. You don't need to do anything yet, but you should add event handler functions and make sure that some code gets triggered as the form is submitted or this reset button is being pressed. But of course, handling events without doing anything isn't too much fun. Therefore, thereafter, as a next step, you should start managing some state. And it's of course also your task to identify the different pieces of state you might want to manage. Keep in mind that there are different ways of managing state, multiple state slices versus bigger objects, and it's totally up to you which approach you prefer and with which solution you come up, but you should identify the state that needs to be managed and you should add the code for managing that state. You should, for example, make sure that all the user input is picked up and used and available when the form is submitted. And you should, of course, make sure that all this investment data that's being derived here is also managed as state somehow. Because it's that data that then later needs to be output when the form is submitted. Now, last but not least, you should, of course, then also use that state to output some data on the screen, to output the results of this investment calculation, to be precise. For that, you should make sure that this table, which you have at the bottom here, is output conditionally, only if data is available. If no data is available yet, because no calculation has been performed yet, you should output some fallback text instead. And you also should make sure that, of course, you output all these rows of that table dynamically, one row per year, because, of course, we are deriving investment data for multiple years here. Last but not least, there is a little bonus task, because you can definitely also dive into styling and either use styled components or anything like that, or maybe at least split up this index CSS file into multiple module CSS files that belong to the individual components that are being used in the application. That is something you also might want to consider doing, and of course also feel free to adjust and tweak these stylings so that they meet your personal preferences. But that being said, this is your starting project. These are your tasks. In the next lecture, so the lecture after this one, you'll get some additional hints that can help you solve these tasks. And thereafter, you'll find my solution where I will solve these tasks step by step. But as mentioned, before you go through my solution, definitely try solving these tasks on your own and try building this application on your own first. So let's now start diving into these different tasks. And of course, I'm going to start with the first task, which is to split this app into some components. Because I did provide this starting project to you, and this starting project at the moment consists of basically only one component, this app component, in this app component file. And whilst this would work and could be used here for this still a relatively basic application, it is a better practice to split your React apps into multiple components where every component has its own clearly defined task and use. And therefore here I'll start by adding a new components folder, And I would say that we could, for example, put this header code here into its own component. Of course, I also then want to put this form into a separate component. And there we could actually also be more granular and, for example, also put every input into its own component. But I'm not going to do that, but I will put my form into a separate component. And last but not least, I also want to put this table into a separate component because I would say that the table, the form, and the header in the end are the three big logical building blocks of this website here, of this web app. Therefore, in the components folder, I'll add a header folder in which I'll add a new header.js file. Then I'll add my user input folder. And of course, these names are up to you, but in there I'll add my user input.js file. And there I'll store that component that will manage this form. And then I'll add one last folder in this components folder, and I'll name it results table. And well, you might guess that in there I'll create a results table.js file. So now with these files created, I'll start in the header.js file. And there we can create a new header component function, either with the function keyword or alternatively with this arrow function syntax, about which you also learned in this course. And that's the syntax I'll use here. And then in this header component function, the goal in the end is to return this header. So this code here should be copied and should be returned here as a result. Now in this code, I'm using this logo, and this logo here is simply this app logo, which I'm importing like this, because that is how you can import images in React projects. And therefore it's now time to copy or to cut this import and move it to this header file. Now the path also must be adjusted, since this header file is nested in the header folder, which itself is nested in the components folder. And therefore from inside this header.js file to reach this assets folder, we first have to go up 2 levels like this, so that then we can dive into the assets folder and reselect this PNG image. With that, we got this header component, and in the app component, we can now replace this div here with header. And for this custom header component to be available here, you of course then also must add an import to it, where you import this header component from the components folder, there the header subfolder, and then the header file, as you learned, without a file extension. Now to see whether this worked, I need to start the development server. And for that, I first need to run npm install in this local project. This is only required once initially to install all these dependencies that are used by the project. And then thereafter, we can start the development server with npm start. And if you now visit localhost 3000, you should see a site that looks something like this. And here we also see the header again. So that worked. Now, of course, the header was only the first component. The next component I want to outsource, or the next code I want to outsource, is this form code. So all that JSX code between the form tags, I'll grab it, cut it from app.js, and move it to the user input.js file. In there, we can now create a new user input component function. And of course, as always, export it as well. And then there, return this form, so that this form JSX code is returned by this user input component. That's the next component added. Of course, it should also be added here then to the app component like this. And of course, again, for it to be available here, you should also add the respective import to the top of your file. Now, as a last step here, I'll get rid of these comments and then cut this table. to also put this into a separate component. So here in results table.js, we can create the results table component function like this, export it as we always do, and then here return this JSX code, this table JSX code. With that back in app.js, we can use results table like this, and of course make sure that it's getting imported in order to be available here. So with that, if we save this, we should see the same web page as before, which of course doesn't work yet, but we also see that all the components are still there, that all the JSX code is still leading to some output being shown on the screen. And therefore, we already completed the first task here, which was to split the app into components. Now, as mentioned, you could of course be more granular. You could, for example, create a separate table head and table body component. You could create a separate component that maybe includes this paragraph that wraps the label and the input. You can do all these things and definitely feel free to do that. For this exercise application here, I am happy with the current split, and we can therefore now move on to the next task. Now the next task is to handle the submit and reset button click events. And for that, of course, we'll need to make sure that whenever these events occur, some code of our choice is getting executed. So therefore, I'm back in the user input.js file, because that's where I got this form. And of course, I wanna, for example, listen to the submission of that form. We can do that, as you learned, by adding the onSubmit prop to this built-in form element, to this built-in form component, which it is in the end. And then we can define a function inside of a function, which you can do in JavaScript, as you learned. And for example, add our submit handler function like this. That's one way of writing it. And we can now set this as a value for onSubmit, like this. So submit handler is passed as a value to onSubmit, and what's important here is that we don't add parentheses, because we don't want to execute this function when this line of code is being parsed. Instead, we want to pass it as a value to onSubmit, so that in the end, React internally can trigger this function here whenever this form here is submitted. Now, when it comes to handling form submissions in React, it is quite common that we want to prevent the default, which we can do by accepting the event argument here, which will be passed in automatically by React when that event occurs. And on that event object, we can call prevent default to make sure that the browser's default behavior is prevented and blocked. Because that default behavior would be to reload the page, which we don't want, because that would reload and therefore in the end restart the React application, which we don't want. So therefore, we're preventing that default so that the page does not get reloaded, and instead our JavaScript code continues to execute and takes over. And here we'll then have to do something once the form was submitted. Now I'll get back to that do something here soon, but before we do something here, I want to add another function, which would be the reset handler. Because we also want to handle the scenario that this reset button here was clicked. That's why I'm adding this reset handler function, because it's now this reset handler function that can be assigned as a value to the onClick prop on this reset button. We don't set the onClick prop on this calculate button, because this button is of type submit and therefore will submit the form, and therefore will lead to this event being triggered. But we do set reset handler as a value on this reset button, so that when this button is clicked, we don't submit the form, but instead we reset it, and we reset all input values to their defaults. Now, of course, we're also going to add some logic for this soon. For the moment, we just added the function though and connected it to the handler. And we can simply console log reset here to see whether this works, and console log submit here in the submit handler. With that, if you go back to your website and you open the browser developer tools, you should see that if you click reset, it says reset here in the console. And if you instead click calculate, it says submit. So those event handlers are working. But these aren't the only event handlers you need to add. Instead, we also got all these input elements here, and even though we're not managing state yet, we'll soon have to manage the values entered by the user as state, and we'll have to listen to changes to those inputs to update the managed state, so to save the values entered by the user. And therefore, we can also add the onChange event to all these inputs and then define a function that should be triggered when that change event occurs. So when the user changes the value in an input. For that, I'll add a new function here, which I'll name changeHandler. And what I'm doing here is I'm defining one function which I then plan to use for all my inputs. So I'll set up a generic event handler function, which I want to reuse for multiple events of the same kind from different sources. For this here, in this change handler, or this input change handler, the name of course is up to you, I'll expect to get two parameters. The first identifier should identify the event source. So in this case, the input for which this event occurred. The second value should then be the value that was entered. And with that, we can now use input change handler in conjunction with the onChange prop. Though we can't set it as a value like this, or to be precise, we could, but we would then not get this information. Instead, I'll create an anonymous arrow function down here as a value for onChange. And in this arrow function, I'll execute input change handler. So here we now need these parentheses to call this input change handler function. But this function will now not be executed when this line of code here is being parsed, but instead only when this arrow function will be executed. And this arrow function, since it's passed as a value to onChange, will only be executed by React whenever the value in this input changes. So therefore, indirectly, input change handler will only be executed when the input value changes. But since we now control the execution of input change handler, or to be precise, we control how it will be executed, we can now also pass some data here to input change handler. And the first piece of data, the first argument, should be this identifier of this input. So that value should be provided. And here for this first input, we could simply use current savings. So this ID here as an identifier. The second value then should be the currently entered value. And for this, of course, we can use the default event object, which will be dispatched by React and which will be passed by React to this arrow function here automatically, because that event object allows us to get access to the event target, which will be this input element, and then its currently entered value. So after reformatting the code, this is how my onChange prop and its value looks like. And this event target value is simply the value that will be provided for this parameter. On the other hand, current savings, this hard-coded string, will be provided as a value for input here. And with that, we now got this generic event handler function, and we can therefore now copy and paste onChange to the next input in line, and just update the identifier here in this case, yearly contribution, for example. And then copy and paste it again to the next input and update the identifier, which now is expected return. And then copy and paste this again one last time to this input, where the ID should be duration. And with that, we're now making sure that for change events on all these inputs, it's always the same change handler function that will be executed, but it will be executed with different identifiers and values. Therefore here, if I console log input and value like this, and I save this, you will see that if you open the developer tools again, if I type 500 to current savings, I'm getting the identifier here and then the value. And of course, the same is the case if I type 10 here into investment duration, identifier and value. So that's working. So now that we're handling events, it's time to start managing state, because that's the next task we have. Now for that, of course, we first of all have to identify the state that should be managed. And of course, as you learned, there typically isn't just a single right or wrong way of building such an application, but I would argue that we probably have some state to manage in the user input component. All these values entered by the user should be managed as state. We need them as state so that we can submit them when that form is submitted. And we also need them as state so that we can reset them if the reset button is clicked. Therefore, in this user input.js file, in this user input component, I'll use state, this use state hook, which is imported from React, to start managing some state. And now the question just is, which state values do we want to manage? And the answer is, well, one for every input, most likely. Because we need to store and use all these input values. And it now in the end comes down to your personal preference, whether you want to manage one state object with multiple keys inside of it, one key per input element, or if you want to have multiple state slices by calling use state multiple times, once for every input element. It's totally up to you, and here I'll go for the one bigger state object, which is being managed here, where I'll have one key per input element. So for example, we could add a key named current savings here to this object. Not like this though, since the dash is not an allowed character like this in a property name. Instead, you have to wrap it in quotes. This is valid JavaScript code and allows you to use property names which otherwise couldn't be used. For example, names that include such a dash. Alternatively, you could of course use camel case notation here. That is totally up to you, but I'll go for the identifier I'm also using on my input. And then we need a value for that key. And for the current savings, so in the end our starting amount of savings we have, we could start with a value of 1,000 or 10,000 or anything like this. Here I'll go for 10,000. Now that's of course not the only key. Instead, we also have this yearly contribution input, which in the end is about getting that amount that will be added every year. And we could set this to 1,200 so that we save $100 per month. The next key value pair in this state object will be the key value pair for the third input, which is the expected return rate. So therefore I'll use this identifier, and here we could set this to 7%, for example. And then the last key I want to manage here is for the last input, which is the duration over which we want to save. Hence, I'll use duration as a key here and maybe set this to 10 years as a default. With that, we're creating this state object, and as you learned, useState now returns an array with exactly 2 elements. And we can use array destructuring to get elements out of this array. And here we'll get the user input and then a set user input state updating function, though as you learned, these names of these elements are up to you. Now the idea now is to call set user input whenever the input change handler is triggered. Because there we want to update this state object here, and store the latest entered values in that state object. Therefore, in input change handler, we want to set our state to a new object, which of course should be based on the old object, because we don't want to discard the values that were not changing. And therefore, as you learned, you should use this function form for updating the state by passing a function to this state updating function. And this function will automatically receive the latest values, so the previously stored user input here, and should then yield a new object representing the new state. So here I'm returning a new state object where I copy my previous input state with the spread operator, so with these 3 dots here, and where I then want to overwrite the value for this one input for which this change handler was triggered. Now here we can use a special JavaScript syntax where we can set a property dynamically, so where we can dynamically access a property name by wrapping the identifier that contains the property name we want to access into square brackets, so that we don't set the property named input, but we instead set the property which name is stored in input. So either current savings or yearly contribution or expected return or duration. So we're setting one of these 4 properties, depending on what's stored in input, to our value. That's how we can dynamically update this state object whenever the input change handler is executed. And with that, we took an important first step. Now at this point, we're not done regarding managing the user input state, though. It's good that we update it whenever an input changes, but of course we, for example, also want to update it when the reset handler is triggered, so when the reset button is executed. Therefore here we should also call set user input, and now in the end reset our state to this initial state. So we can copy this initial state and also use this here in the reset handler. Now copy and pasting is always bad or not ideal, and therefore I'll instead add a new constant outside of my component function, because it doesn't need to be recreated every time the component function executes. And I'll name this initial user input and set this to this object. And now we can use this initial user input constant here to initialize the state here, and to then reset it here in the reset handler, like this. Now, in order to reflect those updated values in our UI, we also must go to those inputs though and set up two-way binding, so that we don't just listen to changes and update our internally managed state, but so that we also pass this updated state back into the input. For that, we can set the value prop to user input, that's the name of our state. And now we need to access the current savings property here, because here we need the value for the current savings input. So with that here, with this code, we access the property named current savings, and we use its value as a value for this input. And this step can and should now be repeated for all inputs, so that here on the second input, we access yearly contribution and set this value as a value for the input. And we do the same for the third input, here for the expected return property. And then last but not least, also here for this last input, where we access the duration property. Here, since this property name doesn't contain a dash, we could also use the dot notation. But to be consistent, I'll use this square bracket access notation. And with that, all these different values are being accessed and fed back to the inputs. And hence, if we reload here, we see our initial values, and we can also update these values. And if I do update them, and I then click reset, you see that we jump back to the initial values. So now that we're gathering all that user input, we now need to find a way of deriving the results that should ultimately be output here in the results table. So we need to get this user input in the end from this user input component to the results table component. Though technically the results table component of course won't care about the user input, but instead on the calculation results. So we'll need to perform the calculation that's set up here in app.js. So in the end, put in other words, we have some state in user input, the user input values, that's the state I mean, which is received in this component, but which in the end, in transformed form, is needed in the results table component. And what do you do if you have a situation like this? Well, you lift state up. That's what you learned in this course. And actually here the app component is already configured to perform this calculation and to receive this user input state. So here lifting the state up is quite straightforward and you don't have to do a lot for it. One thing you need to do though is that in user input, in this component, you'll need to accept props. Because you'll need to accept a function as a prop, a function which you can call instead of user input, but which will be defined in app.js, in the app component. And it's this calculate handler function I mean. This should be triggered in the end when the form is submitted, though as I already mentioned here, we don't want to directly bind it to the submit event, but instead we want to call it indirectly. So for that, here in user input.js, in the submit handler, we could expect that we have a on calculate prop on this component. And of course, since it's your component, this name is totally up to you, but I'm naming it on calculate to make it clear that I want a function as a value for this prop. Because in the end, we want to trigger this function when a certain event occurs, in this case, when the calculate button was clicked. But then I call this function, which I receive on the onCalculate prop, and I'll pass my user input state to it. So that's what we have to do in the user input component. In the app.js component, we now have to set calculate handler, which does want a user input object, as a value for this onCalculate prop. So in app.js, on this user input, we should now add the onCalculate prop. And if you chose a different name here, you also need to use a different name here, as you learned. And then we set onCalculate equal to calculate handler. Now calculate handler already expects to get a user input object, as it turns out, since I'm accessing a bunch of properties here. And therefore, of course, we must make sure that an object of that expected shape here is passed to onCalculate, so to the calculate handler in the end. Now, if you're using different property names in your state here, different names than I am using, you want to use those same names in this code in the app component, in this calculate handler. Because here I am trying to access the current savings property and the yearly contribution property and so on that user input object. So if you're using different property names here, you have to use those different names in your calculate handler as well. With that though, we get all that data, and I'm just going to clean up those comments, and we'll perform this calculation here with that input data to derive the yearly results, and now we need to do something with that yearly data. So what is it that we want to do here? Well, we can now store it as state because that would then allow us to pass that updated data to the results table. So here in the app component, we can also call the use state hook to store our yearly data, and we could set it to null initially, and then here get our results and a set results function like this. And now we could call set results here at the end of calculate handler to pass the yearly data, which in the end is derived in this for loop, as a value to set results. Yearly data. And with that, it would be that yearly data that's managed as state here in the end. Now I said could all the time, because here we can now actually also deviate and change this code, though if that's the solution you used, it absolutely is fine. There's nothing wrong with it and you can stick to it. But here we could also switch to some derived state instead. And instead of storing the final results as state, we could instead get our user input here as well and have a set user input state updating function. And in calculate handler, we can then call set user input and pass the received user input object as a value to this state in the end. And now we can grab all this data here, where we create the yearly data and go through that for loop, and cut it and delete this code here, so that we have a very lean calculate handler function, and instead add it here right inside of the app component function, like this. With that, we would be rerunning this code whenever the state of this app component changes. And that of course means that whenever we receive new user input, so whenever we set this user input state, this component function will re-execute and this code will therefore re-execute. And with that, we would have the yearly data as derived state based on that user input state. Which is a slightly more elegant way of handling that, though as mentioned, if instead you went for the explicitly managed state, that would also be fine. But you should be aware of this alternative. That's why I'm showing it to you here. Now, one problem we'll have with this derived state approach here is that I'm accessing all these properties here which potentially don't exist yet, if we have no user input yet, so if this is null. Therefore, we should actually wrap this code here with a if check, where we check if user input is truthy, and if that's the case, we want to continue here. So all that code should go into this if check, so that we only try to access these properties on user input if it's not null. That's something you should do, because otherwise you'll get an error when trying to run this app. So now with that, we got the state data we need, we're performing all these calculations, and we're getting some yearly data with the details that should be output in the results table. And that's therefore now the next step, that we want to output our results conditionally, and that we also want to show a fallback message if we have no results yet. So let's now make sure that we output the results data and that we do output it conditionally, which means only if we have results. Now for that, back here in the code, I only want to show results table if we have results. Now of course here in this code we could say that we have results if user input is not null. Because if it is null, which is the initial state, all this code where the results are derived will not execute. Which therefore also means that if user input is not null, this code will run and we will have some calculation results. Therefore here we could dynamically output a fallback text if not user input. So if user input is falsy, if it's null, for example, then we could output a paragraph where we say no investment calculated yet, or something like this. On the other hand, we want to output results table if user input is truthy. Because if we have a user input, if it's not null, we'll have performed the calculations here and will therefore have a result. And with that, if we save this, I initially got this text, and the styling of this text is a bit off, but I'll get back to this later. But as soon as I press calculate, we instead get this table. At the moment, this table only outputs some dummy data, but nonetheless, it's a good starting point. So now it's really time to pass our calculation results to the results table and to output the data in the table there. So therefore, the goal in the end is to pass this yearly data here, this array of data, to results table. Because it's this array of data that will in the end contain all the data that should be output in the rows of that table. Because this yearly data will contain one entry per year, and that's exactly what we want to output in results table. Therefore, I'll add a new prop to results table, and I'll simply name it data, though the name of course is up to you. And the value I pass to this prop are my yearly data. So the yearly results data I'm deriving here. That's passed under that data key to results table. In results table, we now want to output that data. So here we should accept props, like this. And then here we want to dynamically loop through these rows. So for that, here we can use curly braces, as we always do. And then access props.data and map our data to these table rows. So here we'll get the data per year, because again, as mentioned, yearly data here will in the end contain one entry, one object of this shape per year, since we're calculating our returns for all these years. And therefore here we'll get the data for a year, and we want to return an updated table row. So that's what we return in map here. And in that row, we now, for example, want to output the number of that year. And for that here, we can access yeardata.year. Why yeardata.year? Because in these objects that are passed to yearly data, we'll have a year key, which is the current loop iteration index plus 1, so that we don't start at 0 but 1 for this year identifier here. In addition to the year identifier, we'll have the interest gained in a year, the savings at the end of that year, and the yearly contribution that was added in that year. So the amount of money that was added to our investment in that year. In the results table, we therefore can output the number of the year by accessing yeardata.year. For the total savings at the end of the year, we can output yeardata.savings. savings end of year. That's this key we have here. For the interest gained in that year, we can output year data dot yearly interest. Yearly interest is another key we have here. Now for the total interest gained, it will be a bit more difficult because here we'll need the year data and there the savings at the end of the year minus our initial investment, which we don't have here yet, we'll add it soon, minus our yearly contribution times the number of years we've been contributing yet. Now for that, at least we have the yearly contribution here. So we have year data dot yearly contribution times year data dot year, because we're making this contribution every year. And since here we want to get the total interest we gained, we have to deduct our initial investment and the ongoing investments we had every year. So therefore it's now the initial investment that's missing, and that data is not part of this yearly data array, but it is part of this user input. Because that user input, which is coming from that form, has the current savings key. And the current savings in the end are our initial investment, the amount we initially invest. Therefore, in app.js, we have the current savings in that user input object, and we can pass that as a prop to results table. There we can add the initial investment prop and set this equal to user input, and then there the current savings. That's our initial investment. And we're now making it available through the initial investment prop in that results table component. So in results table, we now can deduct props.initial investment here from the savings at the end of the year, and also deduct all our yearly contributions to get the total interest gained. Now the last thing I want to output here is the total invested capital, and that in the end is our initial investment plus all our contributions. So basically everything except for the interest we gained over the years. And with that, we're outputting all that data. And therefore, if we now reload this and we click calculate, we get a table with some data in there. Now we're also getting a warning in the console, a warning you should already know from the earlier course sections. And of course, the formatting is a bit off. Now we'll take care of the formatting soon, but before we do that, I want to get rid of that warning by adding a key prop here to this table row. The key should be a unique identifier, and here I'll simply take year data.year, since that will be unique for every year and therefore for every row. So with that, if we save this, reload and click calculate, at least this warning is gone. Now we can work on the formatting. Now when it comes to formatting these numbers as currencies, I gave you a little hint in that hints lecture earlier. You can use a built-in JavaScript feature to format those values. You can create a formatter by using the Intel number format constructor, which is built into JavaScript, which in the end gives you a formatter utility object that provides a method to format numbers as currency, for example. Now again, this code was provided as part of the hints lecture, and you can therefore, of course, directly copy it from there. This formatter can then be used to format that data. For example, the savings at the end of the year can now be formatted by using formatter.format and passing the savings of the year as a value. And I'll do the same for the yearly interest gained, and also for the total interest gained. So I'll wrap this calculation here with format. And I'll do the same for the total capital invested, like this. And that's how we can format all these numbers, and therefore they now look much nicer. And speaking of that, with that we can tackle the last task, the bonus task I gave you, and we can work on the app's styling, or how those styles are being applied, to be precise. So let's now work on the styling. And of course, in general, the app is already styled and, in my opinion, looks quite decent. So I'm not really talking about changing the styles, also because this of course isn't a CSS course, but instead the goal is to change how the styles are applied. And there actually is one place where the style should be changed, and that's here for this fallback text. This doesn't look that great. Now to change that style here, I'll use an approach which you typically won't use too often when building React apps, but which is absolutely fine for this simple use case. I'll add some inline styling to this paragraph. As you learned, you can do this by adding the style prop, and then you set this to an object. That's why you have double curly braces here, not because it's some special styling syntax, but instead because the value that's passed to the style prop here is a JavaScript object, which is created with a pair of curly braces, opening and closing. Here we can then target all these different CSS properties, for example, text align, which I'll simply set to center here. And with that inline styling added here, this fallback text is now centered. But that's the only new style I want to add. What I want to do instead now is I want to break up my existing styles, which I have in the index CSS file, and use CSS modules to apply them to the different components. Now, of course, that's absolutely not something you have to do, but something you can do to make your CSS code more manageable, and something I will do here as an exercise. And therefore, I'll add a header.module.css file, because as you learned, that's how you can use this CSS modules feature, by adding CSS files with names like this. And I'll add a results table.module.css file and a user input.module.css file. And now we can go back to index CSS and start with the code that belongs to the header. Here I'll simply grab the header related CSS rules, cut them, and add them to the header module CSS file. Now, to make sure that these styles still get applied, we have to go to header.js and there import those classes from /header-module.css. And then here, instead of adding the class name like this as a string, we now have to add it as classes.header. With that, if you save this and reload, you should get the same look as before, but now we put the header related styles into this CSS module file. And of course, I'll do the same for the rest of this app as well. For that, I'll continue with the user input related styles by grabbing this form rule here, the input group rule, and all these other rules that are related to the form, including the button rules, like this. Cut them and add them here to user input.module.css. And here this should actually be .button hover. And with that, in user input.js, we of course also have to import classes from /user input.module.css. And now here on the form, we apply classes.form like this. Here for the input group, we apply classes input group like this. since it contains a dash, we have to access this property like this. The dot notation won't work for a property name with a dash. And then further down in this form, or actually for all divs here that wrap multiple inputs, so also for this div, we have to use the same class name, input group. And then further down in this JSX code, here we have to use classes.actions. And then for the button alt, we have to use classes button alt. And for this button, it's classes.button. With that, if we save this, again, it's the same look as before, but now we're using CSS modules. And therefore, last but not least, I'll also cut all the result-related styles and remove them from index CSS so that in there, only my basic page styles remain. And I'll go to results-table.module CSS and paste in those result-related styles. And then in results table, we can import, and we should import classes from /results-table.module.css and replace this string class name here with classes.result. That's the only class in here. And therefore, with that, if we save that and we reload, we get the same look as before, but now we're using CSS modules. So at this point, we completed the first practice project. We built the first demo application in this section. But as mentioned, there will be 2 projects in this section so that you have more opportunities to practice what you learned. Now, the next demo project we're going to build doesn't look too fancy, but will actually come with a couple of nice features, which again allow you to practice building components, managing state, outputting conditional content, and so on. Because in this demo application, users will be able to enter some data about them, to be precise, their username and age. And then once the data is confirmed, the user list is updated and output below the form. But, for example, if you enter invalid data by submitting an empty form, an error modal is shown instead. So this overlay with an error message is shown instead. And this overlay can then also be closed by clicking the OK button or on the backdrop. This overlay should also not just open up if no data was entered, but for example also if an invalid age was entered. To be precise, if a number smaller than 0 was entered. If valid data is entered, another user is added to the list though. So this is the next demo project, and for this project here, you therefore essentially have the following tasks. You should start by building some core components, for example, add user component, which contains this form. You should then, of course, also again start managing some state, like that list of users, for example. And you should, of course, also output that list of users and also, if needed, this error modal, which should be shown conditionally if invalid data was entered, to give the user who's using this website some feedback. Now, attached to the next lecture, you'll find a new starting project, which you can use as a starting point. But this will then be a pretty empty project, because in this upcoming exercise here, unlike in the previous exercise in this section, I want you to try to really build everything from the ground up. And therefore, of course, chances are high that you're going to come up with a pretty different solution than I'll do, but that's absolutely fine. This section here is about practicing what you learned after all. Nonetheless, starting in the next lecture, I will show you my possible solution step by step, and I will show you how I solved these tasks and built this demo project. Attached, you find a simple starting project, basically a pretty empty React application with an empty app component. And once you downloaded and extracted the attached file, you just need to run npm install to install all dependencies, like the React library. And thereafter, once you ran npm install, which I already did here, you run npm start to start this application. And you'll be greeted by such an empty screen because currently there's nothing inside of app.js, nothing inside of our app component. Now, in the application which you saw in the last lecture, I want to have a couple of different areas, a couple of different components. We had that component where we could enter our name and our age. We had that error modal, that error overlay component. We had a button to submit this and to confirm that we saw the error in that error modal. And we, of course, also had that list of users. Therefore, I'll start by roughly planning out the components we'll have. And for that, I'll add a new components folder in which I want to store those components. And I'll add a UI folder for general UI components, which we'll have, like the button. And in components, I'll also add a second folder, and that will be my users folder for all the user-related components. And now in there, we can start adding component files, and I'll start with that component that allows us to add a new user. Hence, here in the users folder, I'll add a new add user.js file, which should hold the logic for us to add a new user. Now, in there, I want to have a React component. So, of course, we have to import React from React, as you learned, because we're going to use some JSX code here. I'll then add my add user component using this function syntax, which we can use in JavaScript, an arrow function stored in a constant. Of course, as I mentioned before, you can also add a function like this. Nothing wrong with that, but I'll go for this approach. And I'll export this as my default so that we can import that component, that function, into another file and use it there. Now, inside of add user, I, in the end, want to render something on the screen which allows the user to enter a name and an age and have a button to confirm all of that. Therefore, in here, I will add a form, let's say. And inside of that form, I want to have a label where I say username. And of course, that should all be returned. So let's wrap it into brackets and then put a return statement in front of it. So there I want to have a label and I want to have an input where the user then is actually able to type that username. And that input will be of type text because I, expect some text there. Now, for accessibility, we can also add an ID here, username. And then on the label, we would add the for attribute normally. Now, for, just like class, is not a name that is available in JSX because these would be reserved JavaScript names. And therefore, it's HTML for, actually. That's the prop name for assigning that for attribute to a label. And with that, we connect it to that input. And that's important for screen readers and so on, so that they understand which label belongs to which input. So we got that. Now I also need another pair of label and input for the age in years, let's say. And here the type will be number because I expect to get a number here. Something like 31, 18, 25, and so on. Now I'll name this age, I'll give it an ID of age, and therefore the HTML4 prop here also has a value of age. And with that I got these two inputs. Now below those I want to have a button of type submit, which will basically submit that form, and here I have add user as my text. So that's a straightforward form. Now on the form here I'll add the onSubmit prop to specify a function that should be executed when that form is submitted. And therefore here I will actually add a new function inside of the add user component function, and that's the, let's say, add user handler function. Now here I expect to get my event object, and I will call event prevent default to prevent that default, which for the submission event is that a request is sent. I don't want that default, hence I prevent it here. And now we can connect onSubmit here to add user handler by passing add user handler like this to onSubmit. Important, as I explained before, don't add parentheses here. This would immediately execute addUserHandler when this line is parsed. Instead, I just want to pass a pointer to that function to the onSubmit prop so that the form component internally can use that function when it needs to use it, i.e. when that form is getting submitted. So with that, we got this addUserHandler here. Now let's go over to app.js and let's import it here. So I import addUser from ./components/users/addUser. And here in the div, we can then add addUser like that. That's how we can add this component here. And if we now save that and go back, we should see this relatively ugly but working component. I can click Add User and the page is not reloading, which proves that this form submission is effectively handled and the default is prevented. So that's the start. Now, some styling would be nice because that doesn't really look the way I want it to look. Now I'll start in index CSS. There you got some basic styling. I'll go to the HTML element here and add a background styling of 1F, 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 like this, and this will give us a nice dark grayish background. Now I also want to wrap this username and age into a card, you could say, into a container with rounded corners and with a white background. And that's therefore something we'll build in the next lecture. Of course, feel free to try this on your own, build such a wrapping container, maybe already with the right styles on your own, and in the next lecture, we'll build it together. So let's build this card component, which I want to have around my form together. So here in addUser, I want to be able to wrap this in a card component, which doesn't exist yet, like this. And that should apply a nice styling here to this form. For that, I'll go to the UI folder and in there add a card.js file. Now in there, I'll create a pretty much standard React component. So we import React from React. We then have card here, which gets props, and we export this as our component. Now, the card component can be fairly trivial. I want to return a div, let's say, and inside of that div, I want to output the content which this card component is wrapped around. So when I wrap card around my form here, this form should of course be output inside of the card. So the card component here should output what's passed between the opening and closing tags of card. And you learned that you can access this content on the special children prop, like this. You put that between curly braces because it's not JSX code, it's a JavaScript expression that should be evaluated inside of the JSX code. And props children will give us that content which is passed between the opening and closing tag of the card component. Now, I will also assign a class here so that we can style it. And now I want to use CSS modules here. You don't need to use that. You could use styled components. You could use regular CSS classes and make sure that you don't repeat class names. But I will use CSS modules. And therefore, I'll add a card.module.css file here where I can specify my card styles. I will add a card class in there, just like this, a normal CSS class. And give it a background of white. Whoops, that should be background. Give it a box shadow of 0, 2 pixels, 8 pixels, RGBA 0000.26, which will add a little bit of a drop shadow to the card, and a border radius of 10 pixels here for rounded corners. Now in card.js, we can import this. Here we can import ./card.module.css. And you'll learn that for CSS modules, you now have to alter this import a little bit. This import would be right if you have a non-module file, if you used regular CSS. But if you want to use that CSS modules feature, you have to import something, for example, classes, from that file. And now here on class name, we can assign one of the classes we have inside of the CSS file. In this case, we of course have only one class, that's the card class. so we can just access classes.card here, and this will assign this generated unique class name to that div. And with that, the only step that is left to have that finished card and to use it is to go to the add user component where I want to use that card and import it here. Because you always need to import what you want to use. If you have a component in a different file and you want to use it in this file, you have to import it from that other file. Otherwise, JavaScript and this React build process here can't make a connection between this file and the file in which your component is defined. So here we can therefore import card from ... to go up one level, so to go out of that users folder into the components folder, and then into UI, and then to card. And you omit the file extension here for JavaScript files. With that, we're importing card, and if we now saved it, it should compile fine. And this looks a little bit nicer, but of course it's still not the final look I want. Now, to get that nicer look, attached you find a CSS file. To be precise, you find the adduser.module.css file. And you can simply drag and drop that, so download it and then drag and drop it into your users folder next to the add user component. This file includes a couple of styles which will help us make this look nicer. Now to use this file, we have to go to add users, to the add user component. And besides importing the card here, we can now also import classes from that newly added CSS file, so from the adduser.module.css file. For non-JavaScript files, you need to add that file extension here. And now to apply that, I want to go to my card and actually add the class name property here and add classes.input. The input class is defined here in the CSS file, and with that we can add it. But now there's one important thing to note. Of course, here, card is our custom component. It's not one of those built-in HTML components. And therefore, since it's our own component, it only has the props, or it only is able to work with the props we use inside of that component. Now, these default HTML components like form, label, input, divs, and so on, they are all pre-configured by React to, for example, work with the class name prop and to then apply a fitting CSS class to the underlying rendered HTML node. Now, for our own component, it of course does not know what to do with the class name prop because it's just our own component, not a built-in HTML component. So we have to go to our own component and make sure that we accept an incoming class name prop and that we do something with it. Now, what do we want to do? In the end, I want to make sure that the CSS class we're applying to the div, with the help of class name on that div, that the classes applied to the div reflect both the card class, which we already are applying, as well as any potentially incoming classes on the class name prop of this card component. So that any class I add here on the card component when I use it is in the end applied together with the card class to the div which is rendered by the card. So I want to apply two CSS classes, one coming from the card module CSS file and one coming from outside, from the props, potentially coming via props. And we can easily make this work. We can add a template literal here as a value for class name on the div, and then inject something dynamically with this $sign curly brace syntax, and add classes.card. That is what we added before as well. But now I'll inject a second value, and that's props.className. Now it's your component, so you could use any property name here. It doesn't have to be class name here on your own props object. I'm just using class name here as well, so that we're able to use our own component just as we work with regular HTML components. I can now set class name on my own component as well, because I'm accepting and using the class name prop here inside of the component. If we would have chosen a different name here, like CSS class, for example, we would need to use that CSS class name here as well when we use the card component. But again, I want to have one API, one way of assigning CSS classes, and therefore I will use class name because that's also what React uses for its built-in HTML components. And with that, we're merging an external class with our internally defined class here. And if I now save this, this now looks much nicer thanks to the styles set up in the add user component. And with that, this looks not too bad. Now let's make sure we also have a nice looking button. And for that, you actually find a file attached to the next lecture, the button.module.css file. And you can use this to try and build your own button. Otherwise, we'll build and use that button together in the next lecture. So, time for a button. Just like a card, a button is a default UI element which we're going to use in different parts of the application. Therefore here I'll add a button.js file, and I already mentioned it, attached you find a button.module.css file, which I'll again download and drag and drop into that UI folder next to the button.js file. Now inside of the button.js file, we can import React from React because we're going to write some JSX code. We can import classes from /button.module.css already. And we can then define our button constant, which is our functional component, and export this as a default. And now in here, I simply want to return the built-in button component, but of course with my default styling applied and with some configuration options. To start with the styling, I'll add class name and point at classes.button. Because in the button.module.css file you'll find that button class, so we can use it thanks to CSS modules to apply a little styling here. I also want to make sure that the type of the button can be set, and I want to make sure it can be set from outside, so from the place where we use our custom button component. Therefore, the value assigned to the type prop on the built-in button component will be dynamic, and I will simply access props.type here, but also provide a fallback in case that should not be set with the OR operator. The alternative is button. So if props type is undefined, this button value will be used as a fallback type for the built-in button. Now, in addition, I'll add onClick, and here I expect to get a handler function via props on my own button component, so I'll simply forward this to props onClick. Now that name here is totally up to you. You don't have to name it onClick, but again, I want to make my own button basically usable like the built-in button, and therefore I use the same naming. So I will have an onClick prop on my button component, and any function received there is just passed on to the built-in button component through its onClick prop. And last but not least here, I also want to be able to output some content between the button tags, and I expect to get that content between the tags of my own button, and therefore we use the special children prop here. That should be all. Now we can go to add user, where we have a button, and use our own custom button. And hopefully I can now just replace built-in button, which is lowercase, with my custom button, which starts with a capital B, per the convention that your component should always start with capital characters. And we now just need to import it, because as I mentioned, you need to import all things you want to use from other files. So here I'll import button from, going up one level, UI, button, like this. And if we now save that, we got this nicer looking button which should work just like the built-in button, because in the end it just wraps the built-in button, of course. But that's the idea behind all React components. In the end, you always compose them all from the built-in HTML components, but you structure them in a certain way and maybe attach certain logic so that you have your own components. And with that looks quite well. Now let's make sure we actually fetch user input, and we then kind of start rendering a list of users below that input form here. Let's continue with this app, and let's make sure we actually fetch user input so that we can then, in the next step, also render it as part of a list of users. We got our add user component here with the add user handler, which is triggered when the form is submitted. And now the goal is to collect the two entered values, the username and the age, and utilize them here. Now to collect the values, we can use a technique we already learned about in the last modules. We can use state management in React to update the state with every keystroke and hence save what the user enters in such a state variable, which is then managed by React. For that, we need to import the useState hook here inside of the addUser component, and then we need to initialize it. For that, we call useState, and we can define the default, the initial starting state. And since I want to manage one piece of state for every input, the starting state will basically be no input, so an empty string. And then I have my entered username here and my state updating function set entered username. Now, in case you're not sure what this syntax means, make sure you go through the respective lectures in the basics module. This is a JavaScript syntax which is called array destructuring, and we use it because useState always returns an array with exactly 2 elements. And with this syntax, we're pulling these elements out of that returned array and we store them in separate constants of the name entered username and set entered username. And I chose those names for those constants because the first element of that returned array is the current state snapshot, and every time this component re-renders, which it for example does when the state is updated, this constant will hold the latest state snapshot. And set entered username on the other hand holds a function which we can call to change that state and to then trigger such a re-render cycle. So now we need a function which is triggered on every keystroke of that input here. And for that, I'll have my username change handler function, for example, where I get the event object because we'll listen to a default DOM event and such events will dispatch objects with more information. And we can bind this to input here through the onChange prop, which then will tie this to the change event listener. So here I pass my username change handler, and therefore this function will be triggered for every keystroke in the input element down there. And now here I will call set entered username, and I want to set it to what the user currently entered, and we can get that entered value with the help of that event object. Because there we can access the target of the event, which is the input, and then the value property of that input to get the currently entered value. Now I'll just copy that and repeat that to also have a age change handler where I call set entered age, because that's the second piece of state I now want to manage. Hence I'll duplicate this as well. And here I have my entered age and set entered age. And with that, we're updating the entered age on every keystroke. We of course also need to make the connection down there. So age change handler. And now we got both the username and the age stored. Now in add user handler, we can therefore now console log entered username and entered age, and entered age, like this. And if we now save everything, we can go back, open up the developer tools here and go to the JavaScript console and maybe enter max here and 31. And if I click add user, you see that output here. Now at the moment, we can also submit an empty form, like an empty age field, but that's something we'll fix later. Generally, fetching that data works. Now as a next step, let's make sure that when we click add user, we actually reset these inputs so that both input fields are empty again. And let's make sure we also have some basic validation, which simply makes sure that nothing happens, that we don't print this information here if one of the two input fields is empty or if the age is smaller than 1, if it's equal to 0 or smaller than 0. So that's something you can try on your own next. We'll do it together in the next lecture, of course. Let's implement that resetting and validation logic together. And let's start with resetting. Resetting generally is easy. Here in add user handler, I just want to call set entered username and set this again to an empty string, and do the same also for set entered age. Now with that, I reset my states to an empty string once I logged the state snapshot here. Now What you'll see, however, is that if I save this and I enter max and 31, we get the output here, but the inputs are actually not cleared. So setting our state snapshots to empty strings doesn't seem to work here, right? Well, it actually does work, but one problem we have is that we don't reflect our current state in the input. That's not a problem as long as we don't want to change it from anywhere else than user keystrokes, but here I want to change it when the form is submitted. So I want to feed the current state for entered username and entered age back into those inputs. And we can easily do that. These input elements have value props, and we can set them to values which will then be reflected in the inputs. And I can set my value of that first input to entered username, and the value of the second input here to entered age. And now I'll reformat that, and with that we'll have inputs which actually reflect the current state snapshot, even if it's not changed through a keystroke, but like here, upon a form submission. So if we now save that and try again, you'll see that now it's cleared. So that's step 1. Now for the validation. For the validation here in add user handler, I want to make sure that all this code here only executes if we have valid inputs. So if neither the name nor the age is empty, and the age is also not smaller than 1. For that we can add a if check here, and check if entered username trimmed is actually empty, which we can check by checking its length. Trim will remove any excess white space, and if it then has a length of 0, we know there is no character in that string, it's an empty string. And if that's the case, or if entered age is empty, so if we have the same check here, then I want to return. For now, I'll not do anything else. If I return here, then this code is not going to execute because return statements finish the function execution. Now I also want to check for my age input value, not just if it's empty, but also if it's not empty, if it's maybe smaller than 1. So I'll have another condition here, another if check, where I check if entered age is smaller than 1. And if that's the case, I also want to return. Now here's one important thing to keep in mind. Entered age is actually a string, not a number. We initialize it to a string here, and anything that's entered into an input is always retrieved as a string. That's just how JavaScript and the DOM and so on works. So we have a string here. Entered age is a string, not a number. Now I'm comparing it to a number here, and generally that should work in JavaScript, but to be super safe, we can force a conversion of entered age to a number by adding a plus here. And with that we ensure that, well, it is a number. With that, if I now save this, you will see that if I click add user, we now got no log here on the right. If I enter max 31 on the other hand, we do get a log. If I enter max and the age is empty, I get no log. And if I enter a negative age, let's say, I also get no log. So our validation, our basic validation here seems to work. Now we'll take care about the error modal later. For now, let's make sure that for the cases where we do get valid inputs, we actually take those inputs and we store the different users in a list, which we then render below the input field. Now again, you can try this on your own. Otherwise, we'll build this together over the next lectures. So let's tackle our list of users next. Now, the first important question is where do we want to output it? And the second question that depends on the first one is where we then actually want to manage our list of users. So where do we want to output that list? We get the user data here in the add user component, and technically we could simply add more HTML code in that component to also render a list. Maybe here, an unordered list below the form. We could then manage our list of users with use state in here in add user and output it down there. That is something we could do, and technically that would absolutely work. But By the way I'm saying this, you already hear that this is probably not how we're going to do it. The idea in React really is that you work with a bunch of components, that you have small, isolated pieces of HTML code and logic where every component really has its own task, its own responsibility, you could say. And therefore, you want to keep your components small and focused. You could certainly argue that a component that fetches user input and then outputs this as a list is focused enough, but I would argue that it's better to have one component that fetches user input. That's this add user component, which we already have. And then we have another component that is responsible for outputting the list of users, so that we split the outputting and the fetching logic into two different components. And therefore, I'll add a brand new component, the users list component, like this. And here, the users list component should be responsible for, well, outputting my user data. Therefore, in there, of course, we're going to write a React component. So let's import React from React so that we can use JSX code. And then here we have users list. We get our props here. And we, of course, export our component here so that we can use it in other files. And then here, I want to, in the end, return an unordered list where I want to go through a list of users, which I, well, need to get in some way, and output a couple of list items for every user. So one list item for every user. How should this work? Well, I think it makes sense to assume that in the users list component, we rely on props to get our actual array of users as data. So here between the unordered list, we could actually use props, let's say users. It's your component, so it's up to you which prop name you expect here. I expect to have a prop property which is named users. And that should hold an array of user data. So we can use the map method, which you learned about in the lists and conditionals module, to map that array of users to an array of JSX elements. So to transform our user data to JSX elements, which then are rendered onto the DOM. So map executes a function on every item in the user's array, and will get that item as an input. Since it's an array of users, I'll name that single item user and write an anonymous arrow function here. And then in this anonymous arrow function, we return a JSX element for every user of that user's array we expect to get on this prop. So the element, the JSX element which I want to render, is simply a list item here. And inside of that list item, I want to output the user name. Let's say we expect user to be an object with a name property. Then we could do it like this. And then thereafter, maybe in parentheses, and that's just text here, not a special React syntax. So between this parentheses text, I want to output, let's say, user.age years old. So my expectation here is that users is an array of user objects where every object has a name property and an age property. Why can I expect this? Because we're the ones creating this app. It's up to us to decide how we want to manage our data, and I want to manage an array of user objects where every object has a name property and an age property. So with that, we have the logic in place to output our users. Some styling would be nice, and for that, I first of all will wrap this list in a card. So I want to have that card component look here as well. So I'll import card again from UI card. And we need to import it here, even though we already imported it in add user, because you need to import what you want to use in a certain component into every component where you want to use it. So it's not enough to just import card once in another component. You need to import it in every component where you want to use the card. With that, we can use card here to wrap the unordered list. And now I also want to have some styling. And for that, you find a users list.module.css file attached, which you can just drag and drop into your users folder. And from there, you know the game, we can import classes from users list.module.css to use that CSS module's feature. And then here on the card, I'll add the class name prop, which I can because a few lectures ago, we made sure that we utilize our incoming class name prop here inside of the card. So we can set it here, we can set that prop, and I set it to classes.user to have not just the default card class on that card component, but also my special user class. Excuse me, users, not user. With that, we got a users list component. Now we need to use it. And that leads us to the next question. Where do we want to use this brand new component? We could use it here in add user. We could use it here below the form, users list like this. We just have to add an import, and we could use it there. That would be fine, but I don't think it makes sense. It's the add user component. If some other developer would have written this component and you would need to use it in your application, would you expect that this component does not just fetch the data and add it, but that it also outputs the user data? By the name add user, it doesn't sound to me like it's going to output anything. It's just about adding something, about getting some data to add something like that. So whilst you again could technically render it here, I think it logically makes more sense to include it somewhere else. And in case you're now wondering how you should decide where to render it, it's your app in the end. You can render things where you want. You can structure your app in the way you want, and the more you work with React, the more you will get a feeling for common patterns and practices. In this course, you will also learn a lot about that and of course see a lot of examples. Here, I want to render the users list in the app component, because that's also where I use add user. So to me, it makes sense that we then have users list here as a component next to add user. So we build our app here. We first have the block for getting that user data. Then we have the block for outputting the user. And below that, we might have other parts in the app, like a footer or something like that. Now to use that users list component here, we need to import users list from /components users list like this. And now we can use it, though it won't work. And actually, whilst we don't get an error here, we do see an error here. Cannot read property map of undefined. Now I told you not to panic when you see an error message, so let's see what's the problem here. It points us at the users list component, line 9, and it shows us the code snippet that's the problem. Here, it's in the end where we call map on the user's prop. This fails because map does not exist on undefined. What does this tell us? It tells us that in the users list component, here, users doesn't seem to be an array, it seems to be undefined. And undefined, of course, is a value type in JavaScript. And indeed, undefined, this value type doesn't have a map method. That is correct. You can't map undefined. Now, why is users undefined? Because in the place where we use users list, so in the app component, we're not setting that user's prop. Keep in mind, I'm extracting users from props. So I expect to get that user's data, that array in the end, on a user's prop on my users list component. So when I use this component in JSX, when I use it as a regular HTML tag in the end, I need to set that user's prop. Or I need to include a check here where I check whether it's undefined and I don't even try to map it. That would be an alternative. But here I of course always want to set it. So in app.js, we need to set the user's prop, and this has to be users because that's the name we are retrieving here. If you picked a different name here, you need to pick a different name here too. But I'm working with users, and we need to set this to an array. And for now, an empty array, of course, does the trick. With that, we don't see a list, but we also don't see an error, and we at least see the card where the list will eventually be rendered. That was a huge step forward. Now let's make sure we actually manage a list of users. We got a list of users which we feed to users list, but it's always an empty array, and that of course is pretty static and doesn't lead to any users being output. Now I want to make sure that when we click that add user button in the add user component, we don't just log that user data here, but instead we really create a new user object with that data, and we add that to an array of users object, which we then output in the users list. And how do we do that? Well, for that we need this concept which was called lifting the state up. We need to manage our list of users in a place where we can get both access to the add user component and, well, get notified when that add user button was clicked, as well as where we got access to the users list component to feed our users array into it. And we don't have access to users list inside of add user, for example. So managing our users list state here would be wrong, our users array. Users list component sounds like the right place because there we need that list, but there we don't get access to the added user data. That add user form is out of reach here. And actually we already configured this users list component to work differently and to get the users data from outside via props. Because that's the place where we want to manage our state. We want to manage it in the app.js component because that's the one component above both add user and users list. It's the nearest component above those two components which has access to both components. And therefore we lift the state management up to this app component. So we want to manage our users array here, and we do this with the use state hook, of course, because it's state of this app, and when that state data changes, the app should re-render. And that's exactly what use state and the state managed by it does. And therefore here we call use state instead of app, and we initialize this with an empty array. Now, as you learned, use state always returns two elements, so we can use array destructuring, and we got our, let's say, users list and a set users list function. And it's now the users list which I want to forward to the users list component. With that, it's still an empty array, but we have a function that allows us to change that array, and then that change would trigger that app component to be re-rendered, and hence the users list component would be updated as well, because it would also be re-rendered since it's part of the app component. So now the missing piece is that when we click the add user button, and hence the add user handler in the add user component runs, we forward the entered username and the entered age to the app component. And we do this with props as well. You learned this as well. We can add a prop here on add user, and we can name it however you want. For example, on add user. And I just use this on something convention because in the end it will kind of work like an event. Now we'll handle it fully ourselves, but in the end it is like an event. When that add user button is clicked, which ultimately happens upon a click on the button, surprise, surprise, then a function which we pass to onAddUser should be triggered. It's a function we have yet to define, and we can define it here, the addUser handler here in the app component. And that's a function where I actually expect two arguments, the username and the user age. And you can name these parameters however you want, of course. I expect to get that data, and with that data, we can create a new user and add it to our list here by calling setUsersList and then updating the state. Now here, I want to update the state by taking the old list and appending a new element to it. And as you also learned earlier, when your state update relies on the previous state, you want to use an alternative form of setUsersList. You want to use that function form where you pass a function to setUsersList. And that function will automatically get the previous latest state snapshot when React performs that state update here. And therefore I'll name that privUsersList. The name is up to you. And you then should return your new state snapshot in the body of this function you passed to setUsersList. So here I'll return an array, a new array, where I first of all copy all elements from priv users list, and that's the spread operator, which simply pulls all elements out of that array and adds them as new elements to this new array. And then I add one new element at the end. I add a new JavaScript object here, which should have a name field. Uname is the value we store there, and a age field, which stores UH as a value. So the two values we get as parameters here. And with that, we create a new JavaScript object for every user, and we add that to our users list array. And now we just need to wire this up. Add user handler is what I pass to the onAddUser prop here on my addUser component. And now inside of the addUser component, we need to utilize this onAddUser prop. So here in addUser, in the addUser handler there, so inside of the addUser component now, instead of console logging, I will call props.onAddUser. And I'll execute it as a function here because I know that what I get as a value on that prop will be a function. Because we're passing a pointer at addUser handler to onAddUser, and addUser handler is a function. So we can execute it as a function inside of the addUser component. And now we just have to forward our two pieces of data, the entered username and the entered age, which we got stored in this addUser component. And with that, we're forwarding that entered data to the app component upon every click on the addUser button here inside of the addUser component. And I know that's a lot of addUser and user, but that's what this app is about in the end. And I want to use names you would realistically also use in real apps. So with that, this function is triggered, and if we now save everything, we should be able to enter max and add a user. Now we're getting a warning here. We'll fix this in a second, but you can tell that this generally seems to work. Now what about this warning? You should know what's causing this, and you should know how to fix it. So here's a quick second for you to pause the video and fix it on your own, and then we'll fix it together. So, do you remember what's causing this? It's a warning thrown by React, and in the end it tells us that every child in a list should have a key prop which has a unique value. React needs this to efficiently update list items and re-render them efficiently. Now we got only one list which we render in this whole application, and that's inside of the users list here, this part. We create a bunch of list items here, and that's exactly the thing that should have a key prop, because it's the item you repeat. So here we should add a key prop, and that in turn should hold a unique value. So something like G1 here is not valid because that's hard-coded, and the same for every list item that's being created. Instead, I think it makes sense that in the place where we create a user, we don't just create a user with name and age, but we also give it an ID. We give it an ID, and that could be math random toString, some pseudo-unique ID. Now every user has an ID that is roughly unique, and inside of our list, we can now utilize this ID field so that the key is set dynamically to user.id. And that ID is now unique for every user. So if we now save this and we retry this, we no longer get any warnings here because now this works as it should. And with that, we're almost done. The missing piece is that modal. Now it's something we haven't built before, but even though it might seem totally different because it's an overlay on the entire page, it's actually not too far away from what we built thus far. So definitely give it a try on your own first, and thereafter we will learn how we can build such a modal together. So we want such an error modal. Now a modal is simply this overlay box, and for me that's a UI element we could be using in different parts of the app. This of course is a trivial app that has only one part, but we're always thinking from the perspective of potentially bigger apps. Therefore, I'll add it in the UI folder because such an error modal could be a reusable UI element. So I'll add my error modal.js file in there, And in that file, we of course import React from React. We got our error modal here, which got props, and we export this like that. Now that's the first step. Now the second step is of course to fill that with some life, and generally it's totally up to you how you want to structure your modal. I actually want to reuse that card, so I'll import card from card like this, and use this as a wrapper for the entire modal. Because I like that rounded corners look and so on, I want to use that therefore. Now inside of that card, my modal should have different sections. I want to have a header with the h2 tag where we actually can output some title. Now below that, I want to have a div which holds my main content, and in there a paragraph with the error message I want to display eventually. And below that, a footer. Now, in that footer, I want to have a button which we can click to close the modal. So for that, I'll import button from ./button to also reuse this component. And this shows this reusability of components. We're using the card in various places of the app. We're using the button in different places of the app. And we only defined these components and their styles once, and we can build our entire UI with these reusable building blocks. That's really the heart and the core idea, or one of the core ideas of React. So we got the button here, and hence in the footer, we can add such a button and say OK, or something like that on it, so that this is our close the modal button in the end. Now, between the h2 tags here, I want to have some title, and of course that modal should be configurable from outside. I don't want to hard code the title and the message into this component. It should also be reusable, so that we can use it in different places of the app to show different error messages. Hence here I output something dynamic between curly braces and use, let's say, props.title. Again, it's your component, you can use any prop name you want here, but I expect to get a title prop which holds the text which should be output here. Now between the paragraphs, I want to output props.message, so that we also expect a message prop which, well, holds the message that should be output here. And I also want some styling. For that attached you find the error modal.module.css file, and you can again just drag that into your UI folder next to the error modal.js file, and then import it here. Import classes from /error modal.module.css. Because I'm also using CSS modules here to have unique class names, and there are a couple of classes that should be attached. For example here, on the card itself, I want to add the classes.modal class, which is one of the classes defined here in the CSS file. In addition, on the header, I want to have the classes.header class, and on that div that surrounds the paragraph, I will add the classes.content class. On the footer, we'll also add a class, and that's the classes.actions class. And these are all CSS classes predefined in that CSS file. With that, we'll have a basic modal, and we can already see that in action. The question is, where do we want to render it? As part of which component? And you can actually argue about that. You can argue that it should be rendered inside of add user, because ultimately it will be this component that will trigger the modal. You could also argue that it's a general overlay over the entire UI, and therefore logically it should be rendered as high as possible in the component tree. Something like inside of the app component or anything like that. Now, I will go for the place where it actually is being caused, and that would be the add user component, but you can definitely also pick a different place. You then, of course, will need to update your state management appropriately. I will write state management code that ensures that it works here inside of the add user component. So here I want to output my error modal, and therefore we have to import it, of course. So we go here and import error modal from UI error modal. Now we also need to configure it. We need to set a title, and we'll soon set this dynamically, but now I'll set it to an error occurred and a message, which we can set to something went wrong. But this will not work, and do you know why? I briefly touched on it in the debugging section. Well, if we try to save this, we'll get an error. We'll get the error that we got adjacent JSX elements and that this is not allowed, basically. Indeed, React doesn't allow two side-by-side components being rendered directly as a root element of your return statement, and you therefore need to wrap this, for example, in an extra div. We'll later see a different solution for this. For now, we'll just take an extra div and put our error modal and our card into that div, so that the div is returned by the return statement, and then inside of the div, we can have adjacent elements. And with that, it compiles, and if you reload, hey, this doesn't look too bad. We got our modal here. Now, of course, it's not dynamic. Of course, we can't close it right now. And of course, one crucial thing is missing, and that's a backdrop for the modal. So an overlay between this modal overlay and the actual main page, so that we can't interact with the rest of the main page, which currently is possible. So, to make sure we can't interact with the rest of the page, back in the error modal, I'll add an extra div next to the card, not inside of it, but next to it, and therefore, as you just learned, we need a general div that wraps both that extra div and the card. And on that extra div, I'll add a class, and that's the classes.backdrop class. The div itself is empty, but this backdrop CSS class makes sure that we have this grayish, black, transparentish background behind the modal. If we now save everything, you can see the background here, and now I can't interact with the form anymore, for example. So with that, we got the modal in place. Now, of course, the goal is to show it only sometimes, only if we do try to submit invalid data, and of course, we want to make sure that we can also dismiss it. So let's make sure we only show the error modal if we entered something invalid. So in the add user component, currently, if we have an empty input or an invalid age, we just return. We cancel this function execution. I want to continue doing that, but in addition, I also want to show an error message in the future. And therefore, we need a way of dynamically showing and hiding this error modal. Put in other words, we need to update our UI conditionally based on the question if we have an error or not. And what does this scream for? State management. We need to manage some error state. And that could be a string, like the error message. That could be an object which bundles error, title, and message, whatever you want. But we need to manage such an error state so that we can set it to we have an error, in which case we want to render the modal, and so that we can set it to we got no error, in which case we render nothing. I mean, we still render the form, but we wouldn't render the modal in that case. So we need an extra piece of state here. Use state, and the initial value is actually undefined, so I don't need to pass any other initial value here between the parentheses. Now I'll name that error and set error, because in the end I'm going to manage some error information here. And now again, it's your app, it's up to you how an error should look like for you, if it's just a string or if it's an object. I will manage an error as an object here. So here, in that first validation part, I will call setError and set this to an object where I want to have a title, like invalid input, and a message where I say, please enter a valid name and age, non-empty values, something like this. And this will set the error state. Now I'll do the exact same here in the second validation function. I'll change the title to invalid age, because here we know that the age is the missing piece and that the age is invalid. And I'll have a different message as well. I'll have a message that says, please enter a valid age greater 0. So that's my error message here. So we set our error state in both cases, but we set it to a slightly different object in both scenarios. The object always has the same properties, and that is important so that we can reliably use it, but the properties hold different values. Now with that error state snapshot will hold that error whenever we call setError, because then the entire component will re-render and error will hold that latest error object as a state snapshot. Hence, we can use that down there in our JSX code to conditionally render the error modal. We just need to check if error is a thing, and if it is, with that AND operator, we output error modal. Otherwise, if error would be undefined, well, nothing would be rendered here for this line. And that is how we can conditionally render a JSX element. We need wrapping curly braces around this because this generally is a JavaScript expression, just one which then also holds a JSX element again. So now the error modal will only be output if we have an error. And now, since the error also is a more complex object with a title and a message, we can utilize that title and message to output it as the actual title and message in our modal. So here I'll bind title to error.title and message, of course, unsurprisingly, to error.message. And with that, if we save this, we get nothing here, but if I submit an empty form, you see here's my modal. Right now we have no way of dismissing it. The button doesn't work yet, but we can of course reload the page for now, so that I also show you the invalid age case. If I enter this, you see I get the invalid age error. So that is working. That works exactly in the way it should. Now let's make sure we can also dismiss it by either clicking on the backdrop or by clicking on the OK button. Now for that, what we need to do, of course, is we need to clear our error state, this error state. Because if we have an error, if what's stored in this state snapshot is truthy, which a JavaScript object is, we'll render the error modal. So the only way of getting rid of that modal is to reset error to undefined or to null or to any other falsy value, so that this condition is no longer met. Now to achieve this, I'll add a new function here, my error handler, which gets no argument, where I simply call setError and set error to null, to set it from an object to null. Null is treated as a falsy value, so now this would no longer be rendered. Now the only question is, how do we trigger this error handler function? Well, I would say from inside the error modal. Because inside of the error modal, we get this button and we get the backdrop. And on both, we want to register clicks and, well, trigger that error handling function. So on the div here, which renders the backdrop, I'll add an onClick prop, which is available on every default HTML component React offers, and trigger the props on confirm function, let's say. Again, it's your component. You can name this prop whatever you want. You can name it on handle error, or as I do it, on confirm, whatever you want. The same for this button. I'll add on click here, and we can add on click here because our custom button component which we're using forwards whatever we pass to on click to the native on click prop. Hence we can add it here. And here I also want to trigger props on confirm. And when I say trigger, I of course mean that on the onConfirm prop, we also expect to get a function which we in the end just forward to the onClick prop, and somewhere down in that component tree, somewhere this will then be bound to the actual DOM element, and a click will trigger the function received on the onConfirm prop. So where do we get that function? Well, in the place where we use error modal. In the add user component, we use error modal So here we now need to add this new onConfirm prop, which I just worked with inside of the error modal. And then here I want to pass in a pointer at the error handler function we defined, so that this is the function which is ultimately triggered when we click on the backdrop or when we click on the button. And with all of that, if we save this, we go back, I can now click here, get my modal, click somewhere on the backdrop, and it disappears. Click on the OK button, it disappears. Let's try a valid input, that works. Let's try an invalid input. We got the modal, we can dismiss it, and of course fix our mistake. And that all works, and that's the finished first app. Now the app itself is nice, but of course not overly complex, as I already mentioned. But we used all those core features and building blocks that are important for React. Components, props, state with the useState hook, lifting state up and all of these things. We used styling, we passed functions between the different components. So all these core patterns and concepts, which you basically need for every React application you're going to build, we have them all in here. And that's why this hopefully was a great practice and why we're now well prepared to continue.